Welcome to Spaceverse, your portal to cosmic adventures. A recent discovery by astronomers using NASA's Transiting Exoplanet Survey satellite, known as TESS, has revealed a planet that is falling apart faster than any other world we've ever observed. This planet, identified as BD plus 054868 AB, is undergoing a truly dramatic end. Its host star is bombarding it so severely that it is shedding mass at an astonishing rate, roughly the equivalent of a moon's worth of material every million years. This is not a slow decline over billions of years. This is planetary collapse on a cosmic countdown. Located about 141 light-years from Earth, BD plus 054868 AB is the closest known exoplanet in the process of disintegration. While its destruction may sound tragic, for astronomers it's a rare scientific gift. The material the planet is shedding gives us a glimpse into layers of a planet that we would otherwise never be able to study, not even here in our own solar system. That's because BD plus 054868 AB isn't just dying, it's giving away its deepest secrets in the process. As part of NASA's mission to catalog and understand planets beyond our solar system, TESS observes thousands of stars, monitoring them for tiny dips in brightness that occur when a planet transits or passes in front of its host star. These brief but regular dips are how astronomers detect distant worlds, sometimes hundreds or even thousands of light-years away. BD plus 054868 AB was detected using this very method by a team of astronomers from the Massachusetts Institute of Technology. What set it apart immediately wasn't just its size or orbit, it was the erratic and dramatic nature of the light curve. The planet wasn't simply blocking light like most others. Its transit showed signs of chaos, a smeared, extended dip consistent with something more than just a planet. What the team discovered was that BD plus 054868 AB leaves behind a massive trail of dust similar to a comet, as it orbits its host star. This trail is evidence of rapid planetary disintegration. The planet itself is incredibly close to its star. It completes a full orbit in just 30.7 hours, less than a day and a half. At just 5.6 million miles, or roughly 9 million kilometers, from its sun-like host star, BD plus 054868 AB is more than 10 times closer to its star than Mercury is to ours. At that range, the level of radiation is intense enough to vaporize rock and strip atmosphere, and that's exactly what appears to be happening. But why is this important? The key lies in what's being lost. As the planet sheds its layers into space, scientists get a rare opportunity to examine the composition of its interior. That material, the planet's very foundation, travels in a tail that can be observed using a technique called spectroscopy. This allows researchers to detect and identify the elements and compounds present in the dust. Nick Tusay, a researcher at Penn State University's Center for Exoplanets and Habitable Worlds, put it succinctly. These planets are literally spilling their guts into space for us. And with the James Webb Space Telescope, we finally have the means to study their composition and see what planets orbiting other stars are really made of. Usually, we can only guess what a planet is made of by looking at its size, density, and the way it orbits. But BD plus 054868 AB is giving scientists direct access to the materials inside it, not just from the surface, but from its interior. And that's what makes this discovery revolutionary. On Earth, for example, we've barely scratched the surface of our own planet's mantle. Deep drilling has only gone down a few miles. Studying the core or even the full mantle is still far beyond our technological reach. But now we're looking at an exoplanet over 140 light-years away that is actively throwing its insides into space. This planet isn't just dissolving, it's teaching. To dig deeper into this dying world, the MIT Discovery team has joined forces with another group of scientists from Penn State. This second group previously developed a method to study another disintegrating planet, K222b, using spectroscopic data. K222b, located roughly 801 light-years away, is also being torn apart by its star, though at a slower rate. What makes BD plus 054868 AB especially exciting is its brightness. Its host star is around 100 times brighter than the star K222b orbits, offering much clearer data. This brightness makes BD plus 054,868 AB a prime candidate for in-depth observation using the James Webb Space Telescope, or JWST. JWST, launched in December 2021, has quickly become one of the most powerful tools astronomers have ever had. It can capture high-resolution infrared images of extremely distant and faint objects. But perhaps even more valuable is its ability to perform precision spectroscopy. With its instruments, JWST can analyze light passing through or reflecting off materials in space, like dust, and determine their elemental makeup. That's exactly what the two teams plan to do. They've already proposed using JWST to focus on BD plus 054,868 AB and analyze the dusty tails it leaves behind. Spectroscopy can reveal the presence of specific elements like magnesium, silicon, iron, and even carbon compounds, all building blocks of rocky worlds like Earth. So how do we know the planet is actually disintegrating and not just dusty? The evidence lies in its highly unusual transit light curve. Most planets produce clean, U-shaped dips in brightness as they block starlight. But BD plus 054,868 AB produces long, skewed, and asymmetric signals. These dips last around 15 hours and change shape from one orbit to the next. The variations strongly suggest that something more dynamic is going on, namely that the planet is being followed by a massive cloud of debris that shifts in size and shape. The MIT team believes the planet emits not one, but two separate tails of dust, one trailing behind it, and one leading it as it orbits the star. These tails are likely composed of different particle sizes. The leading tail contains finer grains, possibly soot-sized, while the trailing tail carries larger particles, more like desert sand. The diversity in grain size affects how the dust interacts with light, which is why the transit signal varies. Mark Hunt, leader of the MIT team, noted, "The planet that is disintegrating and is orbiting BD plus 054,868 has the most prominent dust tails to date. That prominence isn't just visual, it's scientifically vital. The more material the planet sheds, the easier it is for astronomers to study. And the more variation in the dust, the more they can learn about how planets like BD plus 054,868 AB are built." There are over 6,000 confirmed exoplanets in NASA's database. But only a handful of those show signs of disintegration. In fact, when BD plus 054,868 AB was discovered, only 3 such planets were known to exist. All of them orbited faint stars, making them difficult to observe in detail. That's what makes this planet such a breakthrough. Not only is it tearing itself apart at record pace, it's doing so in plain view. Planets that orbit their stars as closely as BD plus 054,868 AB fall into a category called ultra-short period planets, or USPs. These are extreme worlds, most with orbital periods of less than a day. Their proximity to their stars subjects them to intense heat and tidal forces. These forces can cause surface material to vaporize and blow off into space, particularly if the planet lacks a thick atmosphere to hold it together. Interestingly, many USPs are thought to be the remnants of larger planets, possibly Neptune-sized, that have had their atmospheres stripped away by stellar radiation, leaving only the rocky core behind. In the case of BD plus 054,868 AB, we may be witnessing the final act of this process, a rocky core that's now being eroded into nothingness. Jason Wright, a Penn State team member, offered a striking observation. "It's incredible that accurately gauging the inner workings of planets in our solar system is so difficult. We have limited sampling of Earth's mantle and no way to access Mercury, Venus, or Mars, but here we have discovered planets hundreds of light years distant that are ejecting their interiors into space and illuminating them so that we can study them using our spectrographs. It's a powerful reminder that destruction in the cosmos can be as enlightening as creation." While we often focus on the birth of stars and the formation of galaxies, the death of a planet like BD plus 054,868 AB provides a chance to study how planets evolve, lose mass, and ultimately disappear. The two research teams are now waiting for the opportunity to point JWST's instruments at the doomed world. When they do, we may be able to learn what the interiors of rocky planets look like, not from theoretical models or simulations, but from direct evidence. And this evidence won't just help us understand exoplanets. It could tell us more about our own world. After all, the Earth is a rocky planet. If BD plus 054868 AB is similar in structure, its exposed composition might offer clues about Earth's early formation, its mantle chemistry, or even its long-term fate. BD plus 054868 AB is disappearing, but it's doing so on a timeline that, for now, allows us to study it while we still can. As Nick Toucey said, "We are incredibly lucky to be witnessing the final hours of this dying planet. It's a rare event in the cosmos, to see a planet in the process of vanishing and to use that moment to answer some of astronomy's most fundamental questions." And that's the story of BD plus 054868 AB, a doomed, short-lived world offering long-lasting insights. If you found this exploration as captivating as we did, be sure to like this video, subscribe to the channel, and click the notification bell so you never miss a cosmic discovery. The universe is vast and full of stories waiting to be told. Some are about beginnings. Some, like this one, are about endings. Until next time, keep your eyes on the stars.